Building on their earlier experience, Heinkel's engineers set out to create a purpose-built jet fighter. The company's technical director, Robert Lusser, drew up the first sketches of this aircraft in early June 1939. Initially, the project was given the working title HE-180. They envisioned a very fast, highly maneuverable fighter with heavy armament. It would be powered by not one, but two jet engines. Refining the design took about 4 months. The engineers evaluated various cockpit and engine placements, spending countless hours testing scale models in the wind tunnel. The aircraft's final layout came together by the fall of 1939, eventually receiving the official designation HE-280. On September 26th, management officially approved the mock-up. It was a single-seat fighter with a straight wing and very clean aerodynamic lines. Its two engines were housed in underslung nacelles beneath the wings. It also featured a twin tail for added flight stability. For the landing gear, they chose a tricycle layout featuring a nose wheel, an advanced configuration for the time. 3 heavy MG-151 cannons were mounted in the nose. But one of its most unusual features was inside the cockpit. The aircraft had a fully pressurized cockpit and an ejection seat. This allowed the pilot to leave the aircraft at high speeds and extreme altitudes, where a conventional bailout would likely have been fatal. While the airframe and systems development went fairly smoothly, the power plants introduced a host of challenges. The main question was exactly which engines to hang under the wings. Remarkably, even though it was only 1940, Heinkel already had multiple jet engine designs to choose from. Back in October 1939, Heinkel had tasked a group of former Junkers engineers with developing an axial flow turbojet. The project was moving rapidly, helped by the fact that the team, led by Max Adolf Müller, had extensive experience with gas turbines. They brought Heinkel a design that was already well developed. However, their new engine, the HES-30, still needed extensive testing and refinement, which threatened to seriously delay the HE-280's first flight. To solve this, engineer Hans von Ohain came up with a temporary solution. He modified the existing HES-3B centrifugal flow engine, increasing its thrust while reducing its overall diameter. This bought the team some much-needed time. They quickly built, tested, and prepared this new engine for production. Designated the HES-8A, this was the turbojet that powered the first HE-280 prototypes into the air. Meanwhile, development on the more complex HES-30 did not slow down. Heinkel was determined to field a power plant that would clearly outperform the HES-8. He expected that mounting HES-30s on the airframe would significantly improve the fighter's performance. Development of both the aircraft and the engines was moving quickly. This effort received a major boost in March 1940, when the HE-280 project received official backing from the Reich Air Ministry. As a result, Heinkel secured a government contract to build an initial test batch of 9 prototypes. To understand the background of the HE-280 fighter, we first need to look at the state of German jet aviation at the time. Even though operational jet aircraft did not exist yet, jet engine development was already well underway. And this was not limited to Heinkel. As early as 1938, engineers at BMW were working on their own project, the BMW P3302. This would later evolve into the BMW 003 turbojet. Then, in October 1939, Junkers entered the field as well, starting work on the Jumo 004. The aviation industry was approaching a major transition. By then, aircraft designers no longer viewed jet aircraft as pure science fiction. Ernst Heinkel's longtime rival, Willy Messerschmitt, understood that jets were likely to play an important role in the future. That is why, back in the fall of 1938, his company began designing a new interceptor. The design was built around 2 BMW P3302 turbojets, which they planned to integrate directly into the wing roots. The aircraft itself was designed to be relatively compact. According to the original German specifications, it was just over 9 meters long, had a wingspan of around 9.4 meters, and a wing area of 18 square meters. But despite its modest size, it was expected to reach 900 kilometers per hour, roughly 560 miles per hour. That was an exceptionally high speed for the era. The projected performance for this fighter looked very promising, and the airframe would later become the Me-262. Because of this, Messerschmitt secured an official contract from the RLM, the Reich Air Ministry. to build 3 experimental prototypes. This came in March 1940. Interestingly, this was the same period when Heinkel also received approval for a batch of HE-280 test aircraft. From that point on, competition between the two design teams intensified. By the end of September 1940, the first HE-280 prototype was completely assembled. It was transported to a secret Luftwaffe test facility to begin trials, but the team immediately ran into a problem. Its jet engines were not ready yet. Unwilling to lose time, the engineers decided to flight test the aerodynamics of the airframe as an unpowered glider. Instead of actual engines, they mounted empty nacelles under the wings. These mock-ups closely reproduced the weight and aerodynamic drag of the future HES-8A turbojets. Up in the nose, replacing the planned armament, they installed heavy battery ballast. This provided power for the cockpit instruments and test equipment while also allowing the pilot to operate the flaps and cycle the landing gear. Thanks to this workaround, the center of gravity on the unpowered airframe closely matched that of a fully loaded fighter with real engines and ammunition. This glider configuration made its first flight on September 22, 1940, towed into the air by an HE-111 bomber. With experienced test pilot Paul Bader at the controls, everything went smoothly. The second attempt, however, nearly ended in disaster. In early October, during the takeoff roll, the tow cable suddenly snapped. Fortunately, the prototype had not yet lifted off, which was the main reason it avoided serious damage. Shortly after the incident, the aircraft was moved to a different airfield where flight testing resumed. In November, a new company test pilot named Fritz Schaefer joined the program. The flight test schedule was intense and demanding. The engineers wanted data on every possible parameter. They needed to know how the aircraft handled during takeoff and landing. They also evaluated its in-flight stability, as well as the reliability of the landing gear and flight controls. These test flights were relatively short, lasting only 20 to 30 minutes. But throughout the flights, the pilot remained in radio contact with ground control, calling out his control inputs and describing exactly how the aircraft responded. By the summer of 1941, the first prototype had completed over 40 successful towed flights. The test pilots did not report any major complaints about the aerodynamics, stability, or general handling. But the design still needed refinement. For example, engineers had to abandon the unusual lattice speed brakes. Initially, the designers believed these brakes would let the fighter reduce airspeed rapidly right before an attack run. This would give the pilot more time to track the target and line up a shot. But in practice, as soon as the brakes were deployed in flight, the aircraft experienced such strong buffeting that accurate gunnery was impossible. While these unpowered tests were wrapping up, work in the hangars was focused on the next milestone, a powered flight of the HE-280 under its own jet engines. Back in late 1940, engineers had already assembled the next test airframes, which were slated to receive the new HES-8A turbojets. They decided to hold off on building any more prototypes until they had actual flight data from these initial tests. Ernst Heinkel himself was growing increasingly frustrated with the constant delays in engine development, and he had reason to be concerned. By the spring of 1941, the engine was only producing about 1,100 pounds of thrust. This was well below the 1,580 pounds the engineers had projected. Finally, on March 30th, 1941, the fully equipped second HE-280 prototype was rolled out for ground testing. Fritz Schaefer strapped into the cockpit once again, already familiar with handling the aircraft from the unpowered flights. Right before engine start, he insisted that the ground crew completely remove the engine cowlings. That decision turned out to be important. The problem was that the fuel pumps on the HES-8A turbojets were operating erratically. They could not deliver fuel to the combustion chamber at the required pressure. As a result, the fuel atomized poorly and only partially combusted. Unburned fuel leaked out and pooled inside the engine nacelle. Since the engine casing was running red hot during operation, having a puddle of jet fuel sitting right next to it created a serious fire hazard. Interestingly, on this historic day, nobody actually gave Schaefer official clearance to fly. Then again, nobody explicitly told him not to either. Unable to resist the temptation, he decided to take the aircraft up. The flight lasted only 3 minutes. The aircraft lifted off with the landing gear extended, climbed to an altitude of around 800 to 1,000 feet, flew a pattern around the airfield, and touched down safely. The spectators were understandably excited. Right before their eyes, one of the earliest jet fighters had just completed its maiden flight. The team moved quickly to present this new aircraft to the military authorities. In less than a week, the engineers resolved the fuel delivery issues, which meant they could reinstall the engine cowlings. On April 5th, test pilot Paul Bader flew a demonstration flight for officials from the German Aviation Ministry, led by General Ernst Udet. The flight was brief but made a strong impression on the visitors. Udet personally congratulated Ernst Heinkel and promised to support efforts to secure additional production facilities. But it was still far too early to talk about mass production. The main bottleneck remained the engines. They were highly unreliable and had a very short service life. A clear example came right after that demonstration flight. The turbine bearings on both jet engines were completely worn out. Development of the aircraft and its power plants was not moving nearly as fast as Ernst Heinkel wanted. On top of the technical difficulties, Allied bombing raids on the factories in Rostock and Mariannhill were taking a toll. Because of this, in early summer 1942, all testing and production for the HE-280 fighter had to be relocated. Everything was moved to Schwechat, Austria, and the entire design bureau was evacuated there as well. More than a year had passed since the first flight of the HE-280, yet its original HES-8A engine still required extensive work. Faced with these delays, in June 1942, the team decided to fit the second HE-280 prototype with two new Jumo 004A engines. Each of these produced about 1,850 pounds of thrust. On top of that, the fighter was armed with 3 MG-151 cannons. With the new power plants, the aircraft reached an impressive 490 miles per hour. By July, the third prototype took to the skies using the older HES-8A engines, with test pilot Fritz Schaefer back at the controls. This meant engineers were flight testing several different versions of the HE-280 at the same time, using different power plants. The Aviation Ministry, however, was not moving quickly toward mass production. The reason was fairly simple. Since the competing BMW 003 engine was also failing to meet expectations, Willy Messerschmitt had decided to switch to the more reliable Jumo 004A engines as well. On July 18th, his own Me-262 fighter prototype flew for the first time on pure jet power using those same engines. Now the military authorities had an opportunity to evaluate both aircraft side by side and compare them directly. The immaturity of Heinkel's own engine meant that the advantage he had initially gained over Messerschmitt was largely lost. Even so, at this point, Ernst Heinkel was still slightly ahead in the program's development. On November 2nd, the Aviation Ministry issued an official order to build a batch of 24 HE-280 aircraft. These were to be powered by a mix of engines, namely the Jumo 004, the BMW 003, and the HES-8A. The plan was to run side-by-side flight tests with these different power plants. However, this success was short-lived. On November 18th, the order was abruptly canceled. In this uncertain situation, Ernst Heinkel took a major risk. On his own initiative, he arranged a demonstration on December 17, 1942. It was a mock dogfight. The third HE-280 jet prototype, flown by Fritz Schaefer, went up against the FW-190 piston fighter. Making use of the jet's higher speed and stronger vertical performance, Schaefer flew the aircraft to its advantages. According to the account, he achieved a clear success in the exercise. That same day, the jet was flown to the Rechlin Test Center. The transit flight lasted 12 minutes at an altitude of over 13,000 feet. There, the aircraft was shown to another government delegation led by Field Marshal Erhard Milch. Around the same time, Ernst Heinkel proposed a major upgrade of the HE-280 fighter. He suggested a large increase in fuel capacity by widening and lengthening the fuselage. His engineers also wanted to redesign the wing. They planned to replace the twin-tail configuration with a conventional single vertical stabilizer and increase firepower to 6 MG-151 cannons. To power this redesigned aircraft, they proposed using 2 Jumo 004B engines. The mock dogfight and the updated proposal from Heinkel had a noticeable effect. The leadership of the Reich Air Ministry took another look at the HE-280. Interest increased to the point that officials ordered construction to resume. Work restarted on several prototypes that had previously been paused. The ministry even discussed ordering 300 production airframes in a single batch. But Heinkel's factories were already operating at full capacity with other projects, so officials had to look for outside contractors. In early 1943, Heinkel tried to arrange a subcontracting deal with the Siebel Aircraft Company. That effort soon collapsed. The company lacked both the tooling and the factory space for such a complex program. In the end, officials concluded that if the aircraft did enter mass production, it would likely have to be assembled at captured aircraft plants in occupied territories. But in this technological competition, time increasingly favored Willy Messerschmitt. His engineers had produced a promising fighter, even though it still suffered from its own teething problems. The German aviation industry was already stretched to its limit by the war. It could not realistically support the production of two entirely new jet fighters at the same time. Because of this, the ministry leadership had to make a difficult choice. The decision came in late March 1943. Field Marshal Erhard Milch informed Heinkel that the HE-280 program was canceled permanently. All resources were being redirected to the ME-262. From a practical standpoint, the decision was understandable. Thanks to its smaller size, lighter weight, and cleaner aerodynamics, the HE-280 was significantly more maneuverable than its competitor. However, that compact design came with a major drawback. The tight internal layout of the fuselage left very little room for large fuel tanks. Because of this, the fighter had a flight time of only 20 to 25 minutes. By that measure, it had only a fraction of the endurance of Messerschmitt's design. On top of that, the original HES-8 engines never reached the required level of reliability. Attempts to solve the problem by replacing them with the more dependable Jumo 004 engines proved difficult. Those engines were heavier and produced more thrust. That meant engineers would have had to reinforce the HE-280 airframe, increase its dimensions, and expand its fuel capacity. If all of those changes had been made, the result would have come much closer to the ME-262. In addition, Messerschmitt's fighter was better suited to mass production, which was a critical factor under wartime conditions. It is also worth noting that Ernst Heinkel's strained relationship with the Reich Air Ministry, and especially his conflict with Erhard Milch, likely influenced the final outcome. Even though the government officially canceled further development of the HE-280 project, all 9 experimental airframes ordered back in 1940 were ultimately completed. They found a new and important role as flying testbeds for new jet engines. For example, one of the early prototypes was sent to the proving grounds to test the AS-014 pulse jet engine. This engine was intended for the V-1 flying bomb, also known as the Phi-103. It produced roughly 730 pounds of thrust. Under each wing of the aircraft, engineers mounted a cluster of these engines. Before taking the prototype into the air, technicians carried out a series of ground tests. Starting them involved purging the system with compressed air. During the startup procedure, fuel pooled under the aircraft. When the pulse jets finally came to life, flames from the exhaust nozzles ignited the spilled fuel. Fortunately, the fire was extinguished quickly and the airframe was not seriously damaged. Even so, testing was delayed for nearly a month and a half while engineers worked on the engines. The test program did not resume until mid-January 1943. This time, an experienced Argus test pilot named Schenk took the controls. Since the experimental engines did not provide enough thrust for a conventional takeoff, the HE-280 prototype had to be towed into the air. A pair of Bf-110 twin-engine fighters was used for the tow. During the flight, however, a serious technical problem occurred. The tow release mechanism iced over, so when it was time to detach, the system failed. The tow planes released their ends of the cables, leaving the heavy steel cables hanging from the prototype's nose and severely affecting its controls. Schenk had no choice but to abandon the aircraft. He ejected at an altitude of around 7,900 feet. Thanks to his quick reaction, he became the first pilot known to have used an ejection seat successfully in a real emergency. The aircraft itself crashed and was destroyed. Plans were made to continue testing the AS-014 on the 4th HE-280 prototype. However, there is no firm evidence that it actually took part in the program. Overall, very little information has survived about this particular airframe. Only one thing is certain: in 1944, it was towed to the town of Herrsching. There, it was stripped for parts to repair the 7th prototype, which had been badly damaged in a landing accident. The second HE-280 prototype saw extensive flight testing with Jumo 004 engines. However, its story ended on June 26, 1943. It sustained heavy damage during landing and was ultimately written off. The fifth prototype met the same fate in July of that year while undergoing tests with a different jet engine, the HES-8A. The third HE-280 prototype, however, lasted longer than most of the others. Fitted with HES-8A engines, it survived several emergency landings and sustained heavy damage more than once, but the mechanics managed to restore it each time. As a result, the airframe survived the fall of the Third Reich. Along with the sixth and ninth prototypes, it eventually became a captured trophy of the Red Army. The seventh prototype of the HE-280 was completed in April 1943. Interestingly, it was not fitted with engines or even dummy mock-ups. Instead, the aircraft was specifically prepared for unpowered glide tests. To evaluate its handling characteristics, the airframe was handed over to the DFS, the German Glider Research Institute. It made its first aerotow flight behind an HE-111 bomber on April 19, 1943. These unpowered flight tests continued through November. According to some unverified reports, 2 HES-8A turbojets were eventually installed on this seventh prototype, and it flew under its own power until February 1944. At that point, an in-flight engine failure forced the pilot to make a hard emergency landing, which heavily damaged the aircraft. By the time technicians finally repaired the airframe, the engines had again been removed. After that, it was used in comparative glide trials alongside the 8th HE-280 prototype, whose most distinctive feature was an unusual V-tail. It is worth noting that this 8th prototype originally had a standard conventional tail. During the summer and fall of 1943, it underwent extensive flight testing powered by Jumo 004 engines. Later, it received a new configuration with the V-tail installed and its engines removed. In this form, it was also transferred to the Glider Institute in October 1944. For Heinkel's engineers, evaluating the aerodynamic advantages and drawbacks of the V-tail was an important priority. At the time, development of the new HE-162 jet fighter was already underway. Out of 20 proposed design concepts for the new aircraft, 12 featured this V-tail configuration. However, the comparative flight test program for the 7th and 8th prototypes was never completed before the collapse of Nazi Germany. But the story of the HE-280 did not end there. The region containing Heinkel's design bureaus and manufacturing plants fell into the Soviet occupation zone. Between late April and early May 1947, a team of engineers from the Soviet People's Commissariat of the Aviation Industry was sent to Austria. The information gathered on this trip proved valuable. Alongside a large collection of blueprints and technical documents from Heinkel, Soviet specialists recovered actual jet aircraft and engines. This included 3 damaged HE-280 prototypes and several HES-8A turbojets. Unlike the much more famous ME-262, none of the captured HE-280s were restored to flight condition. It remains unclear whether these airframes were shipped to the Soviet Union or examined on site. In any case, Soviet engineers studied the HE-280 closely. The airframes were carefully measured, structural details were documented, and German flight manuals were translated. The result of this work was a series of technical reports published in 1947 by the Central Aerohydrodynamic Institute. These described the HE-280's overall design as well as its landing gear arrangement. Soviet aviation engineers noted the aircraft's good aerodynamics, along with the trailing link design of its main landing gear. They also drew attention to the mechanical linkage between the flaps and the horizontal tail, which automatically adjusted the stabilizer's angle of incidence. In addition, specialists pointed out the accessibility of the cannons and weapon systems. They also commented on the ejection seat and several other advanced design features for the period. However, this generally favorable impression was limited by a major drawback. The airframe was considered impractical for manufacturing and difficult to produce on a large scale. Next, it is worth looking at how Soviet specialists summarized these issues. In their assessment, the main flaw of the HE-280 fighter was the lack of a rational internal layout. This arrangement made final assembly time consuming and unnecessarily complicated the airframe's construction. Looking at the fuselage structure, they concluded that one of the main causes of this awkward layout was the landing gear retraction mechanism. The main gear retracted vertically into the fuselage, taking up too much internal volume. As a result, the cockpit and the aft fuel tank ended up with unusual shapes and angled surfaces. Manufacturing these parts was difficult. In addition, the internal sections of the HE-280 could not be broken down into modular sub-assemblies. This meant the fuselage could not easily be divided into separate sections to simplify assembly line production. Ultimately, during post-war evaluation, Soviet engineers gave the aircraft a harsh verdict and described it as obsolete. But context matters here. Those conclusions were written in 1947, while the HE-280 had made its maiden flight back in 1940. So when weighing the fighter's advantages and shortcomings, one point remains clear. The fact that such a jet aircraft existed while piston engine aviation was still dominant makes it a noteworthy development in the early history of jet flight. The experience Heinkel's engineering team gained from building and testing the HE-280 did not go to waste. Although the project's failure was a serious setback for Ernst Heinkel, work continued. His firm kept developing new turbojets, most notably the HES-011 engine. The company was also working on other jet aircraft concepts. Engineers were not limiting themselves to single and twin-engine high-speed fighters. They were also drafting projects for large jet bombers powered by 4 or even 6 engines. This effort eventually produced results. In the fall of 1944, a decisive moment arrived for Ernst Heinkel. In early September, the German Air Ministry gathered representatives from the leading aircraft manufacturers and laid out new requirements. The military needed a cheap, mass-produced jet fighter. It had to be a single-engine, single-seat aircraft armed with twin cannons. The project was called the Kleinjäger, or Little Hunter. By this point, Nazi Germany was under constant pressure on the front lines, and its strategic resources were rapidly diminishing. Because of this, the concept of building the simplest and cheapest aircraft possible gained support within the ministry. The main criteria were low cost and ease of assembly line production. The use of non-strategic materials, such as mild steel and wood, was also required. In addition, the aircraft needed manageable handling characteristics, and of course, it had to be pushed into production in the shortest possible time. Drawing on earlier research and development, Heinkel's team moved quickly. In less than 2 weeks, they did not just prepare drawings and design sketches for the ministry. They also built and presented a nearly finished full-scale mock-up of the proposed fighter. This proved to be an important factor in winning the contract. Once Luftwaffe officials saw a physical mock-up, the project suddenly appeared far more practical. That was how the HE-162 came into being, the last jet fighter to enter mass production in Nazi Germany. By January 1945, the fighter was already being rushed into production. It met most of the military's requirements. It was suitable for rapid assembly line manufacture and relatively simple to build. It also made extensive use of non-strategic materials such as wood. Even so, thanks to its BMW 003E turbojet, the aircraft's top speed reached about 522 miles per hour, or roughly 840 kilometers an hour. In theory, a high-speed jet like this could have posed a serious threat to American and British piston engine fighters. It was armed with twin 20mm MBY-151 cannons, or in some versions even heavier 30mm Mk-108s. But any success would likely have been limited. By that stage, the Allies were already fielding early jet fighters of their own, and trying to overwhelm them with numbers was unrealistic. Even if the Germans had managed to maintain continuous mass production of the Heinkel 162, they faced another major problem: a severe shortage of qualified pilots. The reason lay partly in the aircraft itself. It proved temperamental and difficult to fly. Keeping it in the air required a high level of training. That was hard to expect from inexperienced young pilots coming out of glider schools and rushed military programs, many of whom were being sent to the front with only limited preparation. While a full history of the Heinkel He 162 is beyond the scope of today's video, this aircraft is relevant here for a reason. When designing the He 162, engineers closely studied its predecessor, the He 280, and learned from its weaknesses and design problems. The experience gained through 5 years of trial and error in early jet development made it possible to create a new fighter in a remarkably short time, about 3 months. Of course, an aircraft designed and built under such pressure was never going to be free of problems. The design requirements contained clear contradictions. The overall concept was flawed from the outset and involved considerable risk. After all, this was meant to be a mass-produced combat aircraft for novice pilots who were expected to make up for limited training through numbers rather than skill. Chief designer Ernst Heinkel seems to have understood that well. In his memoirs, he admitted that while working on the He 162, he did not feel the same creative satisfaction he had known in earlier and more peaceful years. It is not hard to understand why. By that stage, Germany was on the edge of military defeat, and any new technical achievement was inseparable from the broader collapse around it. Decades have passed since that period, and Germany has long since moved beyond it. Over time, one conclusion has become difficult to ignore. German scientists and engineers played an important role in the early development of jet aviation. It is also well known what happened after the war. The Allies dismantled captured German equipment, reverse-engineered it in detail, and carefully studied seized technical documents. Access to that research gave them an opportunity to accelerate their own work in jet aviation and rocketry. That is why the names of those German engineers remain associated with the early history of the jet age. Among them was Ernst Heinkel, one of the designers connected with some of the first jet aircraft of that era.